Okay. And we are now recording. Let's get the program set up from current slide. It'll come up in a minute. First, let me make a couple of announcements. Okay? I don't know if any of you are in a first mini-term class. If you are, you probably know that class is coming rapidly to a close. I think either yesterday or today would be the last day of your class. But what I haven't been saying, I guess I should have, I've been telling my mini-term class is, if you're in a first mini-term class and have not done a student course evaluation for that class, not these classes, but the mini-term 1 classes, please do those. Those are very, very important to us. They're important to me as a department chair because that's one way I can tell what my instructors are doing, usually doing quite well, but I can't tell that unless I see the student course evaluations. I can go in and observe an instructor, and if he knows I'm coming, he can put on a good show that day, okay? But the students see them every day, so I get to find out what that instructor's doing any day of the week, okay, all term long. So please do your student course evaluations. Okay. The other part of that is that as of midnight tonight, that is midterm. Okay. And usually right after midterm, they request from us, the faculty, midterm progress reports. And what that entails is anyone who has a D or an F at midterm. They don't care about A, B's, and C's. You're passing, they're fine. But if you have a D or an F at midterm, then they want to know so they can see if they can intervene some way, get tutoring, counseling, help with whatever might be the issue, okay? So, I know you have 3 possible grades so far, okay? The research paper, quite a few of you have turned in research papers, not half, but quite a few of you. Very nice, okay? Probably my best class of the term as far as percentages, okay? A lot of you have turned in, I'd say, definitely most, have turned in the first quiz. And generally, people did quite well on that. And then we've had the first test, okay? Now, I do want to say this about the first test while I'm here. Don't get discouraged, okay? If the score was lower than you were wanting or anticipating, then don't worry. This is always the lowest score in just about every class I teach. The first chapter, because it covers so much material and it may be sort of new to you. Everything else builds on that. If you got the first stuff down, the rest of it I think you'll find comes a lot easier. Okay, so don't get discouraged yet. But if you did, and I do have your grades out there on Blackboard. Now, if you don't see your test score on Blackboard, that could be one of 2 things. I could have missed it, sorry, or failed to put it in the book, even sorrier. Or I wasn't sure if you were finished with the test. You didn't say do not grade or not finished, but you left some blank, especially toward the end. I wasn't sure if you were finished. If you do want to come back and work on those, I do give that as an option. I've graded the others. It's not going to change anything there. It's only those you left blank. So if any of you did leave blank, and even you may have said not finished, then you shouldn't have a grade out there, okay? So let me know if you are happy with that grade. I'll give you that grade. I've graded it, but I didn't record it because I wasn't sure if you're not coming back to to finish. So please let me know. If you don't see a grade out there, come see me, and we'll find out why, and you can let me know. And here's Carla. Okay. I know you're in here. There you are. Because I just saw you walking up. Okay. So, please, just as I was saying, let me know if you are going to come back and do anything more on the test. Okay. So, usually they ask for these midterm progress reports sometime after midterm, which could be as early as tomorrow. And they could say, get the midterm progress reports in by Friday. I think they'll usually give us a week to do them. So, but anyway, if it happens, it's going to happen usually pretty soon. So if you do need to turn in a research paper to up the grade, turn in your quiz because you don't have a grade. Yeah, that's the other thing. If someone hasn't turned in a quiz, a research paper, and certainly haven't taken the test, guess what you got at midterm? a big 0, and that's going to be in the F category. So please, I'm probably preaching to the choir here. I think all of you are up to speed. But let me know. And even if you do get a midterm progress report thing, you know, like I said, the next 2 chapters we do especially are generally people usually do quite well in those. Okay? So don't get discouraged. This first one's always the hardest test. Okay? Any questions? All right. Let's then get started. Chapter 2 is polynomial and rational functions. Chapter 1 was basically the algebra of functions. I mean, we covered all kinds of functions, all ways. Now we're going to focus on 2 types. The first 5 sections are in polynomial functions, and the last section will be in rational functions. Okay? So, we're starting with 2.1, quadratic functions and models. Now, what is a quadratic function? Say again?
Power to square.
Yes, the power of 2. Okay? The maximum exponent is a 2. Okay, let's back up one slide. What is a polynomial function anyway? Anyone got an idea what a polynomial function is? What does the prefix poly mean? More than 1, okay? Except in math, we count 1 as a polynomial too. So yeah, usually it means more than 1, but we count it. And usually, nomial, I think, comes from the thing name. One name. I mean, many names is what that stands for. Okay? But for us, the names are terms. What are terms? They're things separated by plus or minus signs. Okay? And here's Hamina. There you are. All right. Now, so that's what we're talking about with polynomials. Now, but what makes a term? What makes a term a term? It's not a semester or, no, that's not the kind of term we're talking about. What makes a term? A term can be composed of numbers, variables, and exponents. Okay? Numbers, variables, and exponents, either multiplied together, and the numbers parts can be divided. The variable part cannot be, and the exponents. Now, the exponents have a very limited exponent you can have to be a term in a polynomial. Has to be a counting number. Well, a whole number. Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are your whole numbers. No negatives for exponents. No fractions for exponents. No decimals for exponents. No variables in the denominator, anywhere in the denominator. In fact, the only denominators you can have, numbers can be there, but no thing. So that's what makes a polynomial. They are some of the most powerful, but also the simplest functions to deal with. Later we'll talk about rational functions. We'll wait till we get there. So quadratic functions are polynomial functions with maximum exponent of 2. So the only exponents you can have on the variable, 2, 1, or 0. Of course, if it's a 0, you don't even show the variable. Okay. And then we'll do modeling. Never mind. Not that. Okay. Never that. Okay. Okay, some of the objectives. We'll analyze the graphs of quadratic functions. I think y'all know what they look like already, don't you? Think about it too hard, you probably will realize that. We'll write quadratic functions in standard form. We've been writing them in standard form? No, we've been writing them in standard form for a quadratic equation. That's a little different from standard form for a quadratic function. Okay? And we'll use the results of that in standard form to sketch graphs. You'll find the standard form helps you sketch the graphs much better and more easily. And we'll find minimum and maximum values of quadratic functions in some real-life applications. Okay. So let's start with the graph of a quadratic function. Can anyone right now tell me what a quadratic function will look like as a graph? Parabola, exactly. Parabola can open up or they can open down. Quadratic function is going to look like one of those two. Okay? So in this section, we'll study the graphs of polynomial functions. Okay? So we're supposed to be doing quadratic functions, but they say polynomial functions. You were introduced to the following basic functions. What do we call this one? A linear function. What does the A stand for? The what? It's a coefficient for sure. What is it in the graph of that function? Yes, and what is M? Slope. That's the slope. And what's B? The y-intercept. So you see, this is a linear function. In fact, that's how we write linear functions, always in their simplest form. Now, if we were talking about a linear equation, for some reason books like to do this. They write the linear equation. This is just a little soapbox I get on, so I'll try to get off of it as soon as I can. They'll say ax plus by is equal to c. They'll say that's the standard form of a linear equation. That is a almost worthless form of a linear equation. Why? The a, b, and the c tell you almost nothing. Almost nothing. You have to find out everything on your own. But if you were to write that, what is f of x, by the way? Always. Y is equal to mx plus b. That's also another form of writing a linear equation. Is this any better for graphing than that? Tons better, because you know where you can start with the y-intercept, and then you can do your slope from there. And you can plot every point just knowing those two numbers. Here, those two, A, B, and C, tell you nothing, almost nothing about the graph of the function, the equation. This time. Well, the same thing is going to come out with standard form for a quadratic function. That's going to tell you far more information than the good old standard form for a quadratic equation. We'll get to that later. Okay, what's that function called? Constant. You're reading my hand, aren't you? Okay. And what's this one called? Squaring. You are reading my hand, I can tell. The squaring function. What kind of function is this? Besides being a squaring function? It's a polynomial function for sure. Every one of these is. It's a quadratic function. Why is that a quadratic function? The maximum exponent is 2. You're absolutely right. What's the maximum exponent here? 1. What's the maximum exponent here? 0. There is no exponent. You're absolutely right. Okay, but all three of these are, as you read, polynomial functions. Y'all are real clever. Okay. So here's the definition of a polynomial function. I've tried to say it before. Say it now. Let n be a, notice what the requirements, non-negative, no negatives in your exponents, integer, no fractions, no decimals in your exponents, non-negative integer, and these, a sub n minus 1, and all these a sub 1, 2, and 0, all that kind of stuff, those are just coefficients, and they can be any real numbers in the world. Positive, negative, fractions, decimals, rational, irrational, it doesn't matter. Any real numbers. Now these n's here are just markers saying this is the coefficient that goes with the variable that has that as an exponent, okay? So this is an important part of the problem. This is just a marker that says this is the coefficient that goes with that degree, okay? So the sub-n's don't really, the subscripts don't really mean a lot except where you put them. The superscripts are part of the problem, a real big part. Now, we also require that a sub n not be 0. We said there could be any real numbers in the world, but a sub n has one limitation. Can't be 0. It can be positive, negative, fraction, decimal, rational, irrational. It doesn't matter, but it can't be 0. I wonder why. Oh, we haven't gotten there yet. These are real numbers with a sub n not 0, then this function, f of x, equal to a sub n. Now that's just any old coefficient, any real number coefficient, that goes, except 0, that goes with x raised to the nth power. And a sub n minus 1 is any old real number that goes with the variable raised to the n minus 1 power. And then you walk down the number of powers till you get a sub 2, x squared, a sub 1, x to the first. You don't usually write that. And a sub 0 times x is 0. You don't ever write that at all because that's 1. Anything to the 0th power is 1. This thing is called a polynomial, many terms, okay, of function of x, that's the variable, of degree n. That's why a sub n can't be 0. Because if a sub n was 0, that would be a polynomial of degree n minus 1. It would not be 1 of n degree n. So for this to be of degree n, the a sub n cannot be 0. That's the only reason. Any of the others could be, okay? But this one cannot for it to be of degree n. Degree means the maximum exponent. That's what degree is. It's not how, nothing else. Okay, polynomial functions are classified by degree. For instance, a constant function is what degree? 0 degree, because that's the maximum exponent. There is no exponent. It has degree 0, and that function, what do we call that one? Oh, that's a linear function. What's its degree? 1, because maximum exponent 1. If you don't see a 1, understood it is, okay? As long as a was not 0, because if a was 0, that would be a constant function again, degree 0. So in this section, you'll study second degree polynomial functions, which we call quadratic. Now, why we call them quadratic, I have no clue, okay? Quad to me means 4. There's no 4 associated with it, okay? The only thing I can figure out is when you factor a quadratic expression that is factorable, you wind up with 4 terms. Now, that would be awfully weak reason to call it quadratic. I don't know why they call it quadratic, but that's what they call it. They've always called them that, so you can't change it. Okay. For instance, each of these functions, you tell me, all right, is that a quadratic? This one. Yes, maximum exponent of 2. How about this one? Yeah, because when you expand this, the maximum exponent will be 2. You'll have an x and you know some without. Oh, you can't have fractional coefficients, can you? Sure you can. Any real number can be a coefficient. It's just your variable can't be in the denominator. Any number can be in the denominator, except what number can never be in the denominator? 0. You're absolutely right. Okay, can you have negatives as exponents? I mean, not as exponents, as coefficients? Sure you can. No problem there. Maximum exponent of 2. Wait, I don't see any exponents there. They must have messed this one up. Did they? Why not? When you FOIL it, you get x squared. You're absolutely right. Note that the squaring function is a simple quadratic function, degree 2. All these are a little more complicated, but they're still pretty simple. Okay? So here's the definition of a quadratic function. Let a, b, and c be any real numbers in the world as long as a is what? Not 0. Then this alpha of x equals ax squared plus bx plus c is called a quadratic function. Boy, that looks familiar, doesn't it? What does that look like? Standard form for a quadratic equation if you put equal 0. That would be the standard form for a quadratic equation. Why do we call it that? Because from that place, you can factor it. And if you couldn't factor it, you could use the, oh, this is Math 100. Way back, long time ago. How else could you find the zeros for that? Starts with quadratic. Last name formula? Oh, we've never heard of that, have we? No! Yeah. You better, okay. So, quadratic formula, you can write the answers down, right? X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Yes, we could do that. And here's q. Okay. Anyone else sneak in while I wasn't looking? Okay. Now, so that looks like the standard form for a quadratic equation. We're used to seeing that, aren't we? Guess what? It's not the standard form for a quadratic function. It certainly is one form of a quadratic function because that's a quadratic expression as a function. So it is a quadratic function. It's just not in standard form. We haven't gotten there yet. We'll get there. The graph of a quadratic function, as we've already talked about. Oh, he's through already. Okay. All right. You finished, right? Okay, good deal. Might be graded the next 2 or 3 years. Okay. Now, The graph of quadratic section, you've already said it. What's it going to be? Parabola, opening either up or down. The graph is a special type. I don't really like to call it a U-shaped curve. I understand what they're saying with it, but U's usually go up. These go out as well. Okay? Kelly, right. I was going to say Amina, right? Mm-hmm. Okay. I've got to find you. There you are. Pardon me? I'm sorry?
Did you get it back? I'm
sorry?
Yesterday, did you get it back?
I got it, yes. Okay. But you didn't finish, did you? Yeah. Okay. All right. Okay. I don't like, I understand why they say U-shape, but to me a U goes up like this. A parabola always goes out. You know, it doesn't ever go straight up. It goes straight, close to straight up, but it doesn't. The reason they call it U-shaped curves, it's always smooth and rounded at the bottom, or the top, depending on which way it's facing. So a top wouldn't be U-shaped, it would be something else, okay? That's called a parabola. Parabolas occur in many real-life applications, okay? A fly ball follows the path of a parabola, believe it or not. Absolutely, okay? A fastball follows the path of parabola, believe it or not. It still does. It's always going to be going down. No matter how hard you throw it, it's always going to be going down. A basketball shot, except for, I've never done one, a dunk, okay? Any other basketball shot follows the path of a parabola. A golf shot, everything imaginable, real life applications, a lot of things follow parabolic shapes. Now, ever see a dish or DirecTV thing out there? Guess what shape that is? Paraboloid. Okay? And why is that? Because a parabola has this feature. Okay? This is beyond what the book's talking about now, but parabola has this feature. If anything, a parallel line coming down like this is always going to be reflected to one point. That's called the focus of the parabola. So a dish, you know, as a dish TV, that kind of stuff, it's parabolic shape because it's receiving signals from some satellite up there that it's pointing to, and those are coming in close to parallel, and they always coalesce. You notice that little receiver out in front? Right there. It's focusing all those on that receiver, improving the signal, and that's why you get your signal, because it's a parabolic shape. Ever use a flashlight? Flashlight, that silvered mirror that's behind the bulb that's placed on the focus, it gives close to a parallel beam of light coming out of it, because it's parabolic. Okay. It's not perfect. Why? Because the bulb isn't a point source. It's a big old thing there, so it does have some fray around the edges. Your headlamp of your car, notice that mirror-type surface behind it? Parabolic shape, so your light bulb again right at the focus. Because just like anything coming in, if you have your source at the focus, anything going here is going to come out parallel. Okay? So yeah, that's why your headlamps on your car generally project into a pretty straight beam. The reason they don't is because that's not a perfect point source at the focus. It's got some edges to it, so it does have some fuzziness around the edges, which actually is a good thing too. Okay? So flashlight, reflector, satellite dishes, all those things, parabolic shapes. More than you wanted to know, right? Okay. Now, all parabolas are symmetric with respect to a line called the, what can we name it? Oh, the axis of symmetry, okay? The axis that if you revolved everything around it, looked the same. Or simply the axis of the parabola. The point where the axis intersects the parabola is called the vertex. The vertex is, for one that's opening up, is always the lowest point. The one that's opening downwards, always the highest point. Okay? So we have our max and min already before we even got there, okay? So this. Now, what would make the difference of whether this parabola opens upward or downward? There has to be something that causes it to do that. What would that be? Any ideas? The sign, the SIGN, of that leading coefficient, that A there. If this A is positive, it's opening upward. If the A is negative, it's opening downward. Okay, every time. The leading coefficient is positive, opens up. Leading coefficient negative, it's opening down. Because guess what, folks? In the long run, squaring an x, if your x gets larger and larger, or smaller and smaller, when you square it, it expands. I mean, it's even bigger. Take 10, for instance. Square 10, and what you got? 100. Okay? 100 is going to wipe out any tens or digits that you have there. It's going to do it. Every time. The leading coefficient is going to be the one that dominates, because that the leading term is the one with the maximum exponent. Okay. Make sense? All right. When the leading coefficient is positive, the graph of this opens upward. Okay? When the leading coefficient, though, is negative, it's going to open downward. Because in the long run, it's long Lewis. No. In the long run, you're going to be squaring that variable, very large numbers here. Even a negative number, you square it, and what's it going to be? Positive. Big positive number. And square a positive number, big positive number. But when the A is negative, it flips them over and makes them very, very negative. Okay. So as a parabola opens downward. The simplest type of quadratic function, I sort of disagree with this, but I know what they're talking about. F of x is equal to ax squared. To me, the simplest would be x squared. Okay, our good old squaring function. All the A does is now give it an opportunity to be a vertical stretch, a vertical shrink, or flipped over the x-axis. Okay? Does that make sense? Stuff we did in the last chapter that y'all did really well on your test on, right? Okay. Now, the graph of a parabola whose vertex is 0, 0, that would be one of this graph, the one that we're talking about. Its vertex is going to be 0, 0. Because you see, you have no other terms out here, plus or minus a bx, plus or minus a cx. You have nothing to shift it anywhere. So this one's going to be there at the origin. All you can do, that A, if it's a large A, it's going to stretch it, or a small a, meaning less than 1, it's going to shrink it, or a negative A, it's going to flip it. Okay. Make sense? But we'll pass to the origin. Why? X equals 0. What's f of x? Y is equal to 0, too. 0, 0 is going to be your, on that graph. Make sense? Okay. So when sketching the graph of this, it's helpful to use y is equal to x squared. That's the simplest one, the squaring function, as a reference. And then your A is going to tell you how that is stretched, shrunk, or flipped. Okay? Or flipped and stretched and shrunk. You know, whatever. Any combination of those. Does that make sense? All right. So let's see if it makes sense to you. Sketch the graph of each of these quadratic functions. Compare it with the graph of y is equal to x squared. So let's first draw y is equal to x squared. Okay. I cheated because I know where this is going. I also got it a little crooked there. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. 1, 2, 3, 4, 5. We're not going to need all those. 1, 2, 3, 4. Okay, we're not going to need all those either. Okay. So let's first do y is equal to x squared. Give me a few points. 1 what?
1, 0.
1, 0 will not be on that graph. Because you put a 1 in for x, you don't get a 0 for y. So what would be the y for 1? Second? 1, 1, of course. Okay. There it is. I got that one. Another one. Give me an x. Feel like a cheerleader. I don't look like a cheerleader. Okay. Don't agree with that. Okay. What? 2. Okay. And what would your y be? 4. Got it. Excellent. Okay. Next. Give me another x. Y'all are not very creative today, are you? Imaginative. Open your mind. Give me an X. Anybody? 3. Okay, what would that be? Second? 9. I tried to get 9 on there. I think I did. Okay, there's 3, 9. So all we can go going right on this. Everything else is going to be off scale. Give me another X. Negative what? 1. And what does that give you? 1. Excellent. Okay. Another one? Negative 2 would give you 4. Next. Negative 3 would give you 9. My scale is a little crazy here. Y'all skip my favorite of all time. 0. And what would that give you? 0. Okay. All right. That's not my favorite grade of all time, though. Okay, never mind. All right. Here is what the parabola would look like. Notice it's not going up. It's going out, and it's smooth and rounded at the bottom. Okay? So there's your parabola. That's your y is equal to x squared. So let's do the A part. We'll need a different color. Maybe y'all can give me a color. Is that any easier? Red. Okay, we'll go with red. All right? We'll do f of x in red. Now, what are we doing with f? What are we doing to that one? Multiplying whatever this was, whatever values those are, by 1/3. Or dividing by 3. You could name it that way. So 0, 0, 0 divided by 3 is 0. Okay, that stays there. But 1, 1, 1, the y value is 1 divided by 3 is 1/3. This one was a 4 divided by 3 is 4/3. That's 1 1/3, something about like that. And same thing over here. Okay? 9 divided by 3 would be 3. So that would be there and there. And if, that was 4. I put that in the wrong place, didn't I? It's right there. Okay. Somewhere right there. Okay. I got it too, well, whatever. Somewhere in there. If we had done 4 before, it would have been 16 before. 16 divided by 3 would be 5 1/3. 1, 2, 3, 4, 5 1/3 would be somewhere out here and somewhere out there. Okay? If we had done 5 before, it would have been 25/3. That would be 8 1/3. So that would be up here somewhere and out here somewhere. Okay, you can't, whoops, better have it down here. So here's what that one would be. Okay, what happened here? A shrink, a vertical shrink. An elephant sat on it and, shrunk it down some. Okay, now, color for B, G. What color would that be? Blue for B. Okay. Light or dark? Choose one. Light. Okay. Carolina blue here. Okay. So G is going to be that. What are we doing to those? We're doubling that. So you double 0 and you get 0. That stays that. Double 1 and you get 2 here or 2 there. Okay. Ew, that's ugly. Okay. You double 4 and you get 8, or it's right there, or there I think it is. And the rest we can't show, so this is what the next one looks like. What have you done with that? Stretched, a vertical stretch by twice. Other was a vertical shrink by 1/3. We did that in the last chapter, right? Okay, we're used to this. Here is the comparison in sort of an ugly kind of way. Let me get over and let's see how they do it. So I'm going to erase my scratch. Any comments? Need this a little longer? Everybody got it? All right. And here we have Kendria, right? Oh, I'm sorry, Taylor. Okay. Help me with your last name. Great, okay. No. H, right. Okay, I'm sorry. I misunderstood. Okay. So I thought you were at first, but when you said something, I misunderstood. I said, oh, I've got the wrong person. Sorry. All right. So let's erase this unless there's questions. Are there? Okay, let's see how they do it. Well, they drew in light gray the y is equal to x squared, a good old squaring function. Then for the a part, the f of x, you reduce everything by 1/3. In other words, shrinking it vertically by 3, a factor of 3. And there would be your shrunken one. The elephant sat on it. Okay? But if you did the b one, which is multiplying by 2, that's a vertical stretch. So now these are, every x value is doubled here. I mean, y value is doubled for every given x. So that's a vertical stretch. You had the little toy that you pulled up and the arms went up, that kind of stuff. Okay, vertical stretch. Make sense? All right, same parent function, y is equal to x squared. All right, in that example, note that the coefficient determines how wide the parabola ax squared opens. I wish they wouldn't say how wide. That makes it seem like an x thing. It's really a y thing, okay? When the absolute value of a is small, meaning less than 1, the parabola opens wider than when the absolute value of a is large, in our case greater than 1, and that is a narrow one. Now, what does this do? Y is equal to f of x plus or minus c. What is that going to do? It's what? Okay, no, when you're just adding or subtracting something to either the x or the y, that's a rigid transformation, not non-rigid. The stretching is non-rigid. This is not. What is that called? What are you doing here? If that was a plus c, which way are you going? Say again? Plus c, yeah, you'd be going this way. I have to turn my left and your right. Okay. A minus c, believe it or not, is going this way. When it's doing to the x. Remember, x is always backward. What is this one doing? F of x plus or minus c. What's the plus c do here? It goes up and the minus c goes down. Doesn't change the shape, but it does change the location. What does this do? F of minus x. Flip it across the y-axis, and minus f of x does across the x-axis. That's just like we were talking about before. These are rigid transformations. That was the earlier was a non-rigid. When you multiply or divide by something, that's changing the scale. When you just add or subtract something or negate something, those are rigid transformations. You keep the shape, you just change the location. Okay. So here are some, and I wish they'd have had us do it. Again, here's our y is equal to x squared. If you have a minus x squared plus 1, what are you doing to it? Yep, you're certainly flipping it over, and you're also go up by 1. Now here it's sort of important, flip first, then translate. Because if you translated first and move this up here and then flipped, you would have something down here. So this one is important to, and again, we do what's closest here. Remember, please excuse my dear Aunt Sally, whatever she did. You do the multiplication division before you do addition and subtraction. So you negate it first, that goes here, then you move it up by 1. What does this one do? Left 2 and Down 3. So sure enough, doesn't change the shape because there's no sign change here. So, I mean, change the direction. So you do left 2, down 3. Now, since these are both adding and subtraction, and this one, it doesn't matter, you could have done the down 3 first and then move that. Everything's rigid. It really doesn't matter too much. Okay? So, but still, I like to do it in order so I don't screw up sometime when it does matter. Okay. Any questions on that? Is there a question? No. Okay. Now, let's see where we are. Now we're ready for the good old standard form for a quadratic function. I've had it coming for a while now. Here is what the standard form for a quadratic function. Oh, yuck! I liked ax squared plus bx plus c a lot better, didn't you? No. Those a, b, and c tell you almost nothing. Okay? Just like linear equation ax plus by equals c. The a, b, and c tells you nothing of much. Okay? Whereas y is equal to mx plus b, that tells you everything you need to know the graph. Same thing here. This tells you lots to lead you to doing a graph. Okay? Well, why? This form is especially convenient for sketching a parabola because it identifies first the vertex. The vertex is HK. Now here again, notice this. Your X is followed by the H, always the opposite sign. Okay? It's a negative sign. The K, though, is a positive sign. That tells you what you're doing with the Y. So this has moved the vertex X units to the right, H units to the right, and then moved it up K units. So this HK tells you where the vertex is, HK. Does that make sense? Okay, just like we were doing before. Now what does the A do? A does two things for you. First, the SIGN sign of the A, opening up or down, and then the magnitude of the A tells you stretch or shrunk. Okay, very good. Okay, so the standard form, see, so this way, whereas if you did ax squared plus bx plus c, those a, b, and c, it's the same A, by the way, it tells you the same thing. The b and c tell you almost nothing. The c in one sense is the y-intercept still, but that's about it. Okay. This tells you the vertex, and then really it tells you just about everything you need to know to graph. Okay? So the quadratic function f of x equal a times x minus h squared plus k. That's as long as a is not 0. Why can't a be 0? If a were 0, this would not be a quadratic function. In fact, in this case, it would be a constant function, not even linear. Okay? So yeah, a can't be 0. Otherwise, it would be a quadratic function. Okay, and this is called the standard form. So sort of get that down. The graph of f is a parabola whose axis is a vertical line. Now here's the key. Remember we said the axis is always a vertical line, x equal h. So there's something else it tells you. That form right there tells you the axis of symmetry, or the axis of the parabola. Just change the minus here to an equal. Just put an x with that, x equal h. That's going to be the axis of the parabola. The vertex is going to be the point hk. Notice h is always, it's negative here, but it's positive when you say you change the sign of h to give you the vertex. Keep the same sign of k to get the vertex. When a is positive, you're opening upwards. When a is negative, you're opening downwards. And then it may be stretched or shrunk as well. Okay. So to graph a parabola, it's helpful to begin by writing the quadratic function in standard form. Get it out of the ax squared plus bx plus c. Get it into standard form. Using the process, oh, y'all remember this one, don't you? Completing the square. Oh, that was so much fun back in algebra, wasn't it? Yes, we love doing that. Okay. And we're going to do that in example 2. In that example, you'll notice when completing the square, you add or subtract the square. Boy, You add or subtract the square of half the coefficient of x within the parentheses instead of adding the value to each side of the equation. Huh? Okay. It's a lot easier than what it reads here. And you might say, oh, that makes perfect sense too, but let's do it. Okay. Now, before we do, remind me, what is the standard form? Whoa, where did I get light blue? Who told me that? Okay. All right. F of x equal what standard form? A times x minus h squared plus k. That's pretty easy to remember, isn't it? Okay? If we can get it in that form, we can identify the vertex just by looking at that form. Okay. Now, what appears to be one of the first things you got to do? I'll tell you now, this A is the same as that A. So you got to factor out the 2. So here's my procedure for doing this. Maybe slightly different from the book. I'll rewrite this ever so slightly. F of x is equal to, I'm going to be factoring out the 2, but only of the terms with x in it. Only of those terms. So I'll say 2 times, and what would that be? X squared plus, what? 4x. And then we'll do a big blank. Okay? Don't forget your big blank. It has to be ugly sounding, okay? And then we'll do our plus 7 here. Now, I really haven't changed the value at all. I just changed how it looks, right? Okay? Because if you multiply through, you have 2x squared plus 8x plus 7. Yeah, it's exactly like we had before. But now I've factored out the 2. That was the big thing here. Factored out the a. And that leaves me a form I need to complete the square. Now, do you remember how to complete the square? Okay. If not, I'm going to make up a binomial. Give me a variable, any variable. Second? Variable. X, okay, I'm happy with X. How about plus or a minus sign? You tell me. Minus, okay. And then a number, any number in the world. 6, okay. X minus 6, and I'm going to square that. Now, there's 2 ways to do that. Okay? How would you square that? You tell me.
X squared.
Second?
X squared.
X squared, okay. I'll buy that. Minus, I'll buy that.
Minus 12x.
Ha! 12x plus 36. He remembered the little shortcut, the easy way. And here's what he did. Square the first, twice the product of the 2 with that sign, and square the last. Now, if any of you don't remember that and you want the other way, I'll be glad to do that one too. Anyone want to see that? How you do it otherwise? Foiling. Remember? You want to see that? Foiling is really simple too. X minus x squared is the same as x minus 6 times x minus 6. That's what it means to square something. Multiply it by itself, right? And foiling we would do, first gives you x squared. Then you do the outer. That would give you a minus 6x. And then you do the inner, which is a minus 6x. That's why you twice the product, right? And then you do the last, which is a plus, because minus times minus is plus 36. So that gives you x squared minus 12x plus 36. So notice what we did. We squared the first, twice the product, squared the last. Okay? So what we're going here to complete the square, to make this thing look like a perfect square, we're going to take half of this. Whereas we doubled this, we'll take half of that. And what's half of positive 4? 2. And then we're going to square it because we squared the last. And when you square it, you get 2 squared is 4 plus 4. Okay. But whoops, we've changed the problem, haven't we? Okay? Because we did have a blank here. What we have actually added to the problem is not 4, but 2 times 4, which is 8. That changed the problem. Unless, of course, we subtract 8 over here. Now it's the same, isn't it? Right? Okay. Now guess what, team? You could write this down as a 2 here. That 2 comes right down. And here's what I like to do. I'm going to write the x there without the square. Okay? That's why I factored out the 2, so it would be just the x. As soon as you take half of this, half of positive 4 is positive 2 squared. That is your form. And then what do you have over here? Plus 7 minus 8 is? Huh? Negative 1. Guess what we've got, team? Standard form. Right there. It was that easy. I've tried to make it harder. I can't figure out a way to make it any harder. It's just that easy. Okay? Now, can anyone find the vertex for me? It's what? Just 2? Minus 2. Minus 1. There's the vertex. The opposite of this one and that one, comma that one. Okay? Question? Yeah.
So what if it was 5x instead of
5x, you would factor that out. That would have left a mess here. This would have been 4/5 here. When you divide out of 5, that would be a 4/5. Guess what? You take half of that, 2/5, square it, and you get 4/25. It still works, okay? It just is a lot uglier because of the fractions, thank you very much, but it still works. The procedure still works. Take half of this, square it. As soon as you take half of it, write it down here too, okay? In this form, that's going to be it. Square it, write it here, then subtract off 5 times, what was that, 25 fourths, did I say? 5 times 25 fourths would be 120.
I'm about the middle 4x.
Yeah.
Instead of 4x, it is 5x.
Yeah, that's what I was saying. Okay, before you divide it out to 2, or right here?
Yeah, right.
Oh, right there. Okay. If that was that, you take half of this would be 5 halves, square it, you get 25 fourths, and you subtract 25, or you subtract 2 times 25 fourths. Yeah. Still do the same steps. It's just uglier. The vertex is now going to be a fractional form. That's fine. Those are real numbers. Okay. We love them, but okay, we can deal with them. All right. So we've found the vertex. Oh, what's the axis? Whew, I forgot that. What is the axis of this parabola? I call it AOS, axis of symmetry. Okay? It's what? It's x equal always. X equal what? Negative 2. Always whatever your the opposite of this is. Like I said, if that was a minus sign, you just make it equal. If that's a plus sign, it's equal to minus. Okay? It's just the opposite of this. In other words, it's x equal that. Whatever that is, x equal that, that's the axis of symmetry. Because it's the vertical line going through the vertex. So it's x equal that. So x equal minus 2. Okay? So we've done everything we need except graphing it. So let me erase a lot of this stuff that we don't need to graph it, and then we'll do the rest. So we don't need this. Y'all know that now. We don't need this. Okay. Now we do need that because that's our form. We need those two. We don't need this down here because this is just memory work here. I'll erase my smiley face. I feel so bad about that. Okay. Now let's graph it. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 2, 3. Oh, that's not negative, positive. Okay, what's the first? Where do we start to graph this?
Minus 2 minus
Yes, you start at the vertex. And minus 2 minus 1, how do we get there?
5.
You do what?
This is my third quadrant.
Do what? To the left, how many? 2 and down 1. Got it. There's -2, -1. Okay, if I want to write my axis of symmetry in there, I just take a dotted line and put right through that point. Okay, x equals -2. All right. Now, at this point, I play a little game, okay? I know that we're starting at x equals -2. So starting there, let's take an x 1 away from that. You could either move it 1 to the left, there's -1, or 1 to the right at -3. I don't care. Give me one of those. You pick. Anybody? Either -1 or -3. Pick one. -1. Okay. So let's let x equal -1. So we know we're going to be there. So x equal -1. Okay. Now, in our form here, -1 plus 2 is what? Plus 1 squared is times 2 is -1 is 1. Okay. So that would be right there. -1, 1. Okay. Now, because, what do we call this line here? Axis of symmetry, that means whatever's over here, just go across there, you got the other side. That's why I said I didn't care which one you gave me, because it's going to be identical to that. Ooh, that's too high. Okay. Okay. Now, here's a real easy one. Okay. I said this. This is the only thing this tells you, well, not the only thing. One of the main things it tells you that's worthwhile is the x-intercept. I mean the y-intercept. Where x is equal to 0, what is your y? X equals 0, y is equal to 7. So 1, 2, 3, 4, 5, 6, 7. Somewhere up here is that one. Okay? So guess what? Exactly 2 across here, there's another one. And guess what? After this, you're going to be off scale. So I'm going to draw my parabola, sketch my parabola right there. Oh, it's an ugly sketch, but you get the general idea, right? When you're sketching your parabola, always make sure you have it smooth and rounded at the bottom. No points down there. That doesn't make it. Smooth and rounded. Try to hit the points as close as you can. I didn't do a very good job. But there you have it. Your standard form tells you the vertex. It tells you the axis of symmetry. And then you can even use it to plug in the points, except for one. Go back to this form to plug in the x-intercept. That's such an easy one. And once you have the axis of symmetry, just flip-flop across that. You got it. Does that make sense? Pretty easy to do the graphing this way, rather than plugging in numbers at random and seeing where, oh, that's off scale, where do I find that? Yeah. Let's see how they did it. Any questions before I erase this? Okay. All right, begin by writing the quadratic equation in standard form. Okay, notice the first step is completing the square, but they still just write the equation again, which is fine. Write it down. The first step is getting rid of that 2, factoring out the a, but only do that from your terms with x's in it. Don't worry about this. Move it over here to the side. Okay, they don't leave spaces like I do. Okay, see, they didn't leave a space for it. To me, it makes more sense to drag this over here so you see you're trying to complete and make that a perfect square. Okay? Factor out the 2, whatever's left here, and you do. Okay? Then you do what? Take half of that b, whatever that is, the middle term there. Half of 4 is 2, and then you, what do you do once you take half of it? Square. Okay, so that's going to be a 4. Now, they put the -4 in here. And that's okay, because you're going to multiply 2 times -4 and bring it out here and put -8. I just as soon leave that by itself and say, I'm adding 8 here, subtract 8 here. You're doing the same thing, but here you're doing that. And, yeah. So the procedure here, what steps you do, that's completely up to you. However, you see it best. You're the one doing this. If you like this method, use this method. If you like my method, you're smart. No, I mean, use my method, okay, or anything in between, as long as all the steps are right. After adding and subtracting 4 within the parentheses, you must now regroup the terms to form a perfect square. That's not going to be a perfect square, so you take this minus 8 and move it out there. That's why I really don't care for this too much, but it works, okay? And only they moved the 2 times minus 4 out there. Okay, if you see that better, fine. It just seems a little awkward, but if you like it this way, do it this way, okay? Minus 4 can be removed from inside the parentheses. However, because the 2 is outside, you must haul that as well. So why didn't say plus 2 times the negative 4, I don't know, but whatever, it's the same thing. The minus 8 goes out there. To me, it's just as good to say, hey, I just added 8, subtract 8. That, to me, is so much simpler than moving all this stuff around. But that's just me. I think weirdly. Okay. Now, you're left with this, and this is a perfect square, and it's the perfect square of x plus 2. As soon as you take half of this, that's your plus or minus whatever. Okay. So it's going to be 2 times x plus 2 squared, and then minus 8 plus 7 is minus 1. See? That's your standard form. What's your vertex? Negative 2, negative 1. The opposite of this, h, and whatever k is. Okay? What's your axis of symmetry? Yeah, x equal negative 2. It's an equation. X equal the h, negative 2. Perfect. From this form, you can see that the graph of f is a parabola opening upward. But why is it opening upward? How do you know it's opening upward? The 2 is positive. Exactly. So therefore, it has to be opening upward. Okay? And it's starting down here, but it's opening upward. And let's see, what else was I going to say about it? I guess that's all. Opening upward and has a vertex of negative 2, 1, which you all already identified. Okay, that corresponds to a left shift 2 units, a downshift by 1. Okay, not that kind of downshift. Okay, and then you also have a vertical stretch because of the 2. Okay, they didn't show all that. They just drew it as if everybody could see it. Actually, he didn't draw it very well, did they? They have 1, 1 on this one. They don't have, no, maybe they don't. They have 2, 1 on it. Yeah. 1, 2 on it. Okay. I thought they didn't show that well enough, but they did. Okay. Any questions? Okay. In that figure, you can see the axis of the parabola is the vertical line through the vertex. X equal negative 2. Perfect. Okay? In the figure, I just said that. Okay. To find the x-intercepts of the graph is where it crosses the x-intercepts, where it crosses the x-axis. And what is true about any time something crosses the x-axis? What has to be true? The y is 0. Because on the x-axis, y is neither up or down. It's 0, right? Okay, that's going to give you your x-intercept. So guess what? We go back to our favorite little form, this form. Not the standard form, that form. Just set it equal to 0. Find the x-intercepts. Now, how do you find those? If you can, what's the F word? Factor it, okay? If you can't factor it, use the what? Quadratic formula. Perfect. So when ax squared plus bx plus c does not factor, use the quadratic formula. I even capitalize it here to find the x-intercepts. Because remember, you get a plus or minus. So that's where you get 2. Remember how the parabola may not have x-intercepts. How could that be? Remember we said, let's go back somewhere we can draw, okay? What if this is your, oh, get back there, okay. This is your axis. What if the parabola is up here? No x-intercepts. Or down here, no x-intercepts. So it may be, there will be none. There can also be that it could only have just 1 x-intercept, not 2, where it kisses the x-axis, but doesn't cross it, okay? Or like this, okay? That would be only one. Most of the time, not most of the time, quite often though, you'll have two. No more than two, but two. Okay. I have my watch out. I see the natives are getting restless. It is almost time, isn't it? Oh, yuck. Okay. And by the way, every example has a checkpoint. Okay. So next time we'll start with example 3, which is not here. It's back here. And somewhere here I had a pencil. This will be the top of page 118, example 3. Okay. And I'll erase this one. And I know y'all don't want to leave here without some homework exercises. Oh, there they are. Okay. Oh, look how close we got to finishing 2.1. Ooh, came so close. Okay. Do either, in fact, I would do all of 5 through 8. The answers are in the back and at calchat.com for only 5 and 7, but you should be able to do all 4. Then do either 9 or 11. They're both at CalcChat. 9's at CalcView. Do any of the odds 13 to 25. They're all at CalcChat. 17's at CalcView. It says use technology, but you could probably do it without that. Any of the odds 27 through 33. They should all be at CalcChat. Then you can do 35. That should be at CalcChat. This is going the reverse. They show you the graph. You have to figure out the equation. Oh, wait, sorry. Back up a minute. I would stop at 11. Okay, we haven't done the X and Y intercepts, so we'll stop at 11. We sort of did them, but we just talked about them. So stop at 11, so that's a lot fewer for you to do, but work at them really hard. Okay, all right, good deal. All right, you want to do your, yeah, okay, now you can't stay in this room, there's a class coming in. Okay. What is it? Okay. You waited till after the test. You should have brought this last week, huh? Okay, never mind. Y'all all got one? Yes. Okay.
Oh, I forgot mine, but I need you at least sign it, basically.
Because he forgot his sheet.
Oh, boy. Okay.
Yeah, you can.
Y'all need something else.
I'll be right back. I'm going to take her somewhere, but I'll be
Okay.
back.
Got lots of people waiting here. Quick or what if I dirty?
I just need to take my test because I wasn't here Thursday. I emailed you about it.
Okay. Now, when do you want to take it? Now?
I can take it now or Thursday, whenever it's convenient for you.
Okay. Are you free now?
Yes.
Okay. Amelia's going to be finishing her, so can you wait just a minute? We'll find
Yes,
her.
sir.
Okay. Let me get these signed.
Mission Valley. Is there a place like I can print?
Do you have something?
I just 10 seconds.
The what?
I just need your 10 seconds to
That one of
check
those.
whether it's right.
You need me what?
To check whether it's right or not.
For what?
So you can.
Like copy it?
Yeah.
Okay.
Scanner on
Or
those.
just write it. Write what you write on your paper. Make it like cursive.
They're both of them.
Only thing I see that might be wrong here, you wind up with a +1 here.
You don't have your paper anymore?
So you have to
No, I
subtract
just
three.
think nothing about it.
You see, when you factor this out, okay, put left the 2 there, you take half of that as a -1. And then you square that as a +1. Okay. Okay, yes, but you see it's 3 times +1. 3 down the other thing.
Look, she ain't got the one.
+7.
Yeah, I don't know.
No, it's a plus over here.
It's
So
plus
the-
8.
Yeah, because when you square that, okay, x squared minus 2x plus 1, right? So 3 times plus 1 is 3. So you added 3 here, so you have to subtract 3 there. That would add 1. Okay, well, let me get them taken care of. And I'll see you this afternoon tomorrow. We can talk about it.
Hey, Mr. Val.
All right. Brandon.
Bro, it's fine.
No research.
Yeah, but Luis is gonna freak out.
You probably will, you know how he is.
Bro, I didn't give him 2 of my classes last year. He just said, "What's your grades?" And I told him. He said, "Okay." He doesn't care.
I was asking him to go copy it. I mean, I'm sure he can copy that paper somewhere. Straight. I'll be doing the same thing.
I wouldn't. It's like I said, I'll probably not even. I'll have like a SEMA online class. You know what I'm gonna do? Screenshot it, print it out, and just give it to him.
Or just staple the paper that you write on to the back of that one and give it to him.
Brandon's done for.
Thank you.
That one's yours, dude.
Yeah, that one's mine.
Okay.
That one's mine.
All right.
Just like,
What?
because he wrote with basketball.
Yeah, no, he's supposed to. And then Lewis looks at it like how many days we missed on that day.
Actually, I didn't do it backwards. This has test quiz, which is sort of backwards, but anyway.
Wants to chat. You know how he is.
Okay, we should all have like
I'm gonna have 30 minutes soon.
thanks, sir.
This is Dylan.
Sir.
You can put your name in it.
I know I missed that one day because of the doctors. So I may have one more than y'all. Yeah, we're gonna get you just like if I could print a copy of that paper off, but then it's just like. Yes. And just like squeeze the rest of what I miss.
Oh. Wait, I'm looking.
So you ain't gotta count the day I went to the doctor.
I do.
I think that was last class. I don't know if I needed to bring you my excuse for the last time I missed. Because I was at the doctor the last class. Okay.
I understand that, but it still was. You haven't taken any tests yet, right?
No,
Oh, you
sir.
just did. I haven't
Just
graded
did.
it yet, right?
Thank you.
Okay. Sorry that took so long.
Oh, me?